Hello, my name is Dr. Piyush Chaudhary. I joined medicine 37 years ago, and I'm in surgery since past 28 years almost. Since last few years, I've also given some time to artificial intelligence in surgery and finally devised a system that can be integrated across laparoscopic and robotic surgeries for live monitoring, skill refinement, and a personalized feedback on subjects that deal with surgical ethics, corporate commitments of reaching targets, insurances, doctor patient trust relationships, and adding the component of transparency in surgery, which is so aptly required in our world. My topic for the day is real time monitoring for ethically reflexive artificial intelligence in robotic and laparoscopic surgeries. Now, what is the problem and what is the motivation required? The surgeons are facing a cognitive overload and ethical blind spots in the OT. The current metrics are for time and error rate, which miss ethical reflexivity, and real time quantifiable measures of cognitive and ethical states are required to improve performance and safety. So what we need to do is to quantify metrics and which can capture real-time ethical cognition and performance. What we are seeing here is a task performance and ethical alignment between, which is a trade-off between task performance and ethical alignment. And if you see the optimal balance which we are getting is a combined reward is zero point 0.6 task and zero point 0.4 ethics. So that is where the optimal balance is coming from. What are the key metrics which will be actually required in this case? That is the ERDI and REX. ERDI is Ethically Reflexive Divergence Index, which measures divergence during ethical cognitive conflicts. REX is your reflexive ethical control stability, which captures stability of ethical reflexivity under cognitive load. And that enables quantifiable monitoring of surgeon cognition and ethics during procedures. Now, what we are seeing here is a gallbladder. We all know this is a procedure of laparoscopic cholecystectomy in which we keep seeing the gallbladder, the cystic duct, and the cystic artery, but there is a certain form of uncertainty that is always there, which is present, and you're not sure whether you're going to do it there directly or you might have to open it up and without injuring the CBD, which is the common bile duct. And there are a few more structures which should be adding here also. That is your uveus sulcus and the edge of the liver, which needs to be added here. Now, what happens is that the uncertainty heat map overlay orange red area is the one which really causes the trouble here. And that is because this uncertainty which is there is unable to predict whether you're on the right track or not. Now, this uncertainty that is there is your quantifying how confident your AI model is about each segmentation it performs during surgery using, and that uses a Monte Carlo dropout or a deep ensembles the AI model outputs, which probability maps for each pixel. Low confidence means high uncertainty and high confidence is for low uncertainty. So what we need is high confidence here. And the example that we are going to get is that AI is able to detect the cystic duct but shows low confidence near its junction with the CBD. And that is flagging off this as a high uncertainty area. So orange is the uncertainty area. The guidance which we are going to get from this AI is that we can detect structures directly and areas that can be injured, which are the uncertainty areas which are there. So what happens is that this cognitive measure of reflexibility is going to tell you exactly that the surgeon is comfortable in identifying this feature or not. If the surgeon is not comfortable, then that is going to reflect in its actions. And that can be documented. And also you can know whether the surgeon was on the right track or whether the anatomy which was there was very sort of undissectable. Okay. So what we are going to go move on to the next slide. The next slide is a heat map of the 4 parts of the laparoscopic cholecystectomy procedure, in which the first is the axis, the second is the dissection, third is the clipping and extraction, and fourth is the closure. So the heat map across procedure timeline, the x-axis is the procedure time, the y-axis is the combined ERDI and RECS metrics, And this highlights phases with high cognitive load and ethical instability, which supports target training focus. That means you need a higher training for these particular procedures. And this kind of algorithm can help you reach that stage. So now we are just going to go through these ERDI versus time stimulation. This thing graphs this ERDI across the timeline of laparoscopic cholecystectomy stimulation, and there are spikes which indicate a high cognitive ethical conflict moments, and there are highlights of the surgeon's ethical reflexivity stress points, which can be measured if we go through this. Then there is obviously a task reward, there is an ethical reward, ERDI, and combined reward, in which we can see that the combined reward and the task reward and ethical rewards are not very different here. The ethical reward is at the one which obviously which you want to everybody wants to stay ethical all the time, but that may fluctuate by time and that may fluctuate by the actual difficulty of the operation. So what is happening is that we can try to measure whether the computer or this software can just tell you whether you're on the right track or not while you're operating such a case. And it's not only this case, it could be any case. And this is just an example of laparoscopic cholecystectomy, which has come here. This could be anything further. So then we have other graphs like REX and action frequency, then PPO training reward process. What is the impact and implications that enables real-time quantifiable ethical cognition monitoring, potential for live feedback loops during trainings and surgeries, align surgical practices with safety, skill improvement and ethical decision making, and paves way for the ethically reflexive co-pilots in surgery. So this is the conclusion, and I hope to hear from you soon. Thank you so much.